It's a pleasure for me to be here and present to that audience in this nice town of Budapest. So, my name is Rene Kriedemann. I'm from Secondwave Wireless LAN Consulting, and I like to talk about ARDF at 2.4 gigahertz, or as the radio amateur would say, at 13 centimeters band. So, just at the beginning, one word about Secondwave. What is Secondwave? Secondwave is Rene's Wi-Fi design studio. Founded in 2003, I did several millions of square meters of Wi-Fi infrastructures in the past, office in Berlin, and a temp office in Sopron, which is in Hungary in the western part. So I do, beside designing Wi-Fi training. I'm the EKH certified survey engineer trainer for German language. And next week I will do, for instance, the next training. So, next. What is ARDF? It is amateur radio distance finding. And it is a sport, yeah, and outdoor activity. Do we have radio amateurs in the room? Ah, Keith. That's why he liked it. So you may remember. Did you ever did this kind of fox hunting or fox soaring or geofoxing, which you can call it? It is done in the 2-meter band or in the 80-meter band. That's what I learned. There are different flavors of it, and if you remember. The relationship between the speed of light and the wavelengths, you could find out what frequency they used. 150 megahertz and 3.4 megahertz for this kind of fox hunting. What is the method? What are they doing outside? They have to have a device which is able to detect a signal from a transmitter. The transmitter is distributed in the country, and the people try to find it. So for that, they have to select the right frequency, which is fixed in the device for them. That means they have to tune in to the right frequency, and then they start to search these transmitter in the countryside based on the measurement of the received signal strength. So, if the received signal strength goes up, we are on the way to find the device. And then they have to mark it, and most of the time they do it 5 times, and the guy who did the distance the fastest way won. Yeah, that's the play about that. Of course, they will not destroy the transmitters, but I choose that word because some transmitters we will face in the 2.4 and 5 gigahertz bands, we should destroy if we find them. Yeah, so now it comes to that point. What are we doing? We do a kind of spectrum analysis. So we detect a signal from a transmitter. Yeah. What kind of transmitter it is depends. It could be Wi-Fi, but we all know, especially in the 2.4 gigahertz band, you will have some or a lot of non-Wi-Fi transmitters. So you have to detect them, and the tool for that is a spectrum analysis tool, because this is independent from the Wi-Fi packet forms and all that stuff. So just the physical layer. Yeah. So of course you have to select signals because we have a very wide spectrum, especially in the 2.4, and that means you have to find out which part of spectrum would be interesting for you. Yeah, and you have to find out this based on the signals you will see in the whole band. So you have to select the problematic signal. Not each signal you will see is real problematic. Yeah? And if you have select one, which is problematic, you can start to search it based on the measured signal strength. So if you go closer, you will be on your way to find it. So, and some real problematic things you should search and then destroy. So, I will just show you some samples during that little... Does it run? Yeah, now it runs. You will see just some screens during that little video from my things I tried out. I tried out a radio control with a drone, how it is in the spectrum. Yeah, that is what you can see at 2.4 if you try to control a drone. Yeah. So I have it with me, so if someone is bored later on, he can come to that table I grabbed over there and we can play with the devices. This is what you normally see, yeah, in the 2.4 gigahertz band. And this is something which is problematic. It just goes away there. And it came from that guy. Yeah. And this will show you that not only at the 2.4 gigahertz band, you will find problematic devices in this waterfall screen. Also, of course, in the 5 gig. Yeah. This, by the way, came from the drone at the 5.8. Yeah. So, I have some time left. That's cool. Let's do a little demo. So, I have several spectrum analysis tools with me. Will not call them all except this, which one will only grab from my dead hands, cold dead hands. Yeah. So, and I have all the other stuff except from the manufacturer will spend the beer tonight. So, let's switch to the application I have prepared here. So now we see live the 2.4 gigahertz spectrum. I don't have to explain the channels, all that stuff I think everybody knows. And now I should have one of the problematic guys with me. This one. Let's switch it on. Put it this way. I think there's nothing to add. Yeah. Of course, if I go away from my detection device, the amplitude will go down. You can see it in the heat map here. So, and if you change to the so-called waterfall thing, you will see how it changed in that. Now we are close. Yeah. And I go away now. It will go down. The activity go down because the received signal strength is going down. So, of course, you can do it on the better way. You can try to select a special part of your spectrum. Let's say this. And you have several tools available in the market. I have several with me at my table there, where you can choose the part of the spectrum and then use a kind of device finder which will show you the signal strengths over time and help you to find your guy. Yeah. So, and if one has the time for that, I could hide one of these devices and one could try to find it. Yeah, so just over the table. So I'm already done. Just for information, I put the actual presentation on the Dropbox over there. You can find it on the stick. And yeah, any questions? No, because I'm done.